Hi everyone, this is Mrs. Mata, and this video is about constant of proportionality, and particularly we will focus on tables and graphs. This first table is when x is time and y is distance. So it shows the number of miles a plane traveled while in flight, and we will use this information to determine the approximate constant rate of change in miles per minute. So I'm going to highlight constant rate of change. And when you see constant rate of change, I want you to think about K. And when K equals Y divided by X. So let's find some values to find K. So constant rate of change is K, and we have some X values here and some Y values here. I'm going to go ahead and just use the least amount, the less amount. So when y is 290, x is 30. And you have to start with the y in the numerator and then the x in the denominator to divide. So let's get the y, which is 290, and we will divide that by the x, which is 30. So in order to get that, we do top in, bottom out. And I'll end up with 9 2/3. So miles per minute, we have 9 2/3 miles the plane travels per 1 minute, which is again unit rate. We could be asked for the unit rate, or we could be asked for the constant rate of change. Either way, we go ahead and use this formula here, y divided by x. Here's another example that has number of buses, x, to number of students, y. And we are determining the constant rate of change in students per bus. So our answer is going to be a certain amount of students per, and it'll be per bus. So per one bus, there are blank amount of students. Same thing, we're finding the constant rate of change, which is y over x. So the y value here is 144, and the x value that corresponds to 144 is 2. So I'm going to do top and bottom out and divide 144 by 2. I end up with 72, so my answer is 72 students per bus. In this example, they just give us a table. So I can do the same thing. The constant rate of change would be any y value divided by the x value. And if the change is constant throughout all of the x and y's, then it's a constant rate of change. So y here is 6 over 1, and this is 12 over 2. This one's 18 over 3, and then you have 24 over 4. And you want to make sure that these rates of change are constant throughout the whole thing. 6 divided by 1 is 6, 12 divided by 2 is 6, 18 divided by 3 is 6, and 24 divided by 4 is 6. So the constant rate of change is 6. Here's one more example with the table. So again, here is the x value here and the y value. So when y is 18, x is 2. When y is 36, x is 4. Next we have 54 and 6. And the last one is 72 and 8. And you'll notice that if you divide each of these out, you will get 9 for all of them, which means the constant rate of change equals 9. Or we can write it as y equals 9x. Here's an example where we see a table and then we see a graph. So in this example, they want us to compare two families, Guzmans to Hashimoto's. And they're giving us the two different representations saying the same thing. So what we could do is we could put the values that are in the graph in a table to compare to Guzman so we can see how that's going to compare. So we would have hours as our x, and we would have distance in miles as our y. And we're just going to take the points in the graph and put them straight into the table. So when x is 2, y would be 120. When x is 3, y is 180. And then when x is 4, y would be 240. So now that I have the graph turned into the table here, I can compare the Guzman's table to the Hashimoto's table and see which family averaged fewer miles per hour. In order to do that, I have to find the constant rate of change for each of the families. So the Guzman family and the Hashimoto family, I want to know what K equals so I can see which one is fewer. For the Guzman road trip, I'm going to take the y value of 90, and when y is 90, the x is 2. And 90 divided by 2 is 45, so the Guzman, we figured, was 45 miles per hour. And we can justify that also by choosing a couple of other ones just to make sure. 135 divided by 3, that should be 45. And then the 180 divided by 4, that should be 45. So constant rate of change, miles per hour, 45 miles per hour. So I'm going to write that over here. Let's find the Hashimoto miles per hour. So we have when y is 120, x is 2, which means 120 divided by 2, you get 45. Just kidding. You get 60. So that tells me that the Hashimoto, I'm just going to put H, is 60 miles per hour. So that's their K, their constant rate of change is 60. And if I take 180 divided by 3, I'd get 60. And if I take 240 divided by 4, I'd get 60. So the question again is asking which family averaged fewer miles per hour, which means my answer is the Guzman family, because 45 miles per hour is fewer than 60. So the Guzman family would be the answer here. Here's number 6. There's a graph at the right. I want to predict the number of chocolate chip cookies in 9 pancakes. So if we look at the x-axis, we have the number of pancakes and the number of chocolate chips. And 9 is right here, so I want to predict the 9. In order to do that, let's find the constant rate of change and then just plug that right in. So y equals kx, and let's see what the constant rate of change is by grabbing a value from the line and substituting that in for k and x. So here's the line right here. If you can't tell, it goes up like this. So let's go ahead and grab when x is 2. When x is 2, y would be 16. So 2 comma 16 is the value of this point, and we are going to substitute that into our constant proportionality equation. Y is 16, and then we have a k, which we're trying to figure out, and then the x value is 2. So in order to solve, we would divide both sides by 2, and then k would equal 8. So last, we're going to rewrite this equation. Instead of y equals kx, we're going to rewrite it as y equals 8x. That tells us that however many pancakes there are, we multiply by 8 to get the number of chocolate chips. So if we can predict the number of chocolate chips in 9 pancakes, y equals 8 times 9, we can say there probably is 72 chocolate chips in 9 pancakes. So this A value right here, 72, would be the answer. Now they want us to predict the number of pancakes that would have 48 chocolate chips. Well, remember, chocolate chips right here is the y value. So if I know that my chocolate chips is 48, 48 equals, and I know that my constant rate of change is 8, then I can get my x. Same thing you would do to the other equation, divide both sides by 8, and then you would get the number of pancakes, which would be the x. So 6 pancakes has 48 chocolate chips. So on this one, the answer is 6. The 0.18 means in this situation that when we have one pancake, there are 8 chocolate chips. So an answer for this one would be the unit rate. For one pancake, we can say there are 8 chocolate chips. And that's what the 0.18 means in this situation. And the last one says, which of the equations represents this situation? Well, we already figured that out, which was right here. So our answer is B. Here we have a ratio table, and we want to show ratios that are equivalent to 4 to 18. So 4 would be in this top, and 18 would be down here. So we can extend the table 4 to 18. We also need to know our unit rate, because if we know our unit rate, then we can figure out the rule and figure out all the missing variables. So the unit rate is y divided by x. So the y in this case is 18 and the x is 4. 18 divided by 4 would give us 4, and then we'd have 2 left over, so 4.5. So the rule is whatever the x is multiplied by 4.5 would give us the y. So 4.5 would be the 1, and 48 times 1.5, sorry, 4.5 would give us 216. So we wrote that in there. Here we see 160, and so when x is 160, what is y? And so this tells us 160, which is x, times 4.5 is going to give us y. And the product I got was 720. This next one is a little different because instead of figuring out the y, we want to know the x. However, we still know that y equals 4.5x. So if we know y, in this case, which is 20, 20 equals 4.5x. So now if we want to know x, we would divide both sides by 4.5. And now we have 20 divided by 4.5. This needs to move over once, and you add a 0 here. What we ended up getting for that is 4.4 repeating, so I'm just going to write that as the x value. Here's another one where I'm finding the y value here for the x value of 8. So I'm going to take 8 and multiply by 4.5, running out of workspace. 4.5 times 8, and this becomes 36. So 8 times 4.5 is 36, so that goes there. And then once again, you have a missing y value or an x value instead of a y value. So instead of multiplying, remember we divide. Because we have y equals 4.5x, we know that 90 equals 4.5x. And then in order to find x, we do the opposite, which is divide. And we have 90 divided by 4.5, which would give us our x. So then you go top and bottom out. Move the decimal over once, add a 0, and you end up with 20. So I completed the ratio table depending on the missing variables. I either had y missing or x missing. So the missing variables were all filled in because I figured out first this 1 over 4.5, that's the key, and then you have this formula that you use to find all of the missing variables in the ratio table. Here's a circumstance where we have fruit punch and it uses 1.5 cups of orange juice for every cup of apple juice. So I already know what I can write inside of my table down here. So it says a cup of apple juice, which means 1 cup. And then for every 1 cup, it's 1.5. So I have 2 cups is 3, 3, 4, 5. And then you just add 1.5 every time. 4.5, 6, and 7.5. Next, I want to write an equation that can be used to show the relationship. So an equation in a relationship of proportionality is y equals kx. This means that we have k, which is what we're multiplying x by each time to get y. And in this case, y equals 1.5x, because whatever x is, we multiply by 1.5 to get y. Every time we multiply by 1.5, and we'll be able to get our y value. The last step is to represent this information in the graph below. So all we will do is take the points from the graph, and x comes first, so 1 comma 1.5, and go over 1 and up 1.5. And then we would just put a point there. Same thing for the next one. We would go 2 over and 3 up. And so that would be there. And you would just keep going with 3.3 and 4.5. You would do 4 comma 6. And then you would do 5 and 7.5. So just graph those on the coordinate plane. Once you have all the points graphed, you want to connect them with a line. So it's best to use a ruler at this point to connect them with a straight line. I have a straight line on my iPad, so it's just going to go through the point exactly through the middle. And the most accurate you can be, the better. Like that. Now that we've graphed this relationship, there's one more question, and it says, how many cups of orange juice are needed for 12 cups of apple juice? So remember our equation? We want apple juice, which is 12, and I know that I'm going to put that in for x because apple juice is x right here. So y equals 1.5 times 12. I have 12 cups of apple juice. I want to know how many orange juice cups do I need. 1.5 times 12 will give me that answer. And I get 18. So I need 18 cups of orange juice for 12 cups of apple juice. I hope that this video has helped you practice using tables and using graphs with constant of proportionality, which is y equals kx. Remember, to get constant of proportionality, you take the y value minus the x value. And if it's constant in all of the y's and the x's, then it is the constant of proportionality. Thank you for watching.